In this section, we will delve into the concepts of client credentials and password grant, crucial components related to API security. Understanding these grant types is essential for safeguarding your API interactions. First, we will discuss the client credentials grant, which is ideal for server-to-server communications where no user interaction is involved. This type is particularly useful for machine-to-machine authentication. Next, we'll explore the password grant, which involves using a user's credentials. This approach is typically used when the API provides direct access to resources on behalf of the user. We'll also touch on the relevance of these grant types to API security, ensuring that you can implement them effectively in various scenarios. Practical application tips will be provided to help you integrate these methods securely and efficiently. By the end of this section, you'll have a solid understanding of how client credentials and password grant work and how to apply them to enhance your API security.
In this module, our primary focus will be to understand the two OAuth 2.0 grant types, the Client Credentials Grant and the Password Grant. We'll delve into the key differences between these grant types and explore scenarios in which each is appropriately applied. It's essential to grasp these distinctions to effectively implement secure, efficient API security measures. By the end of this section, you should be able to identify when to use each grant type and understand their respective advantages and limitations in securing API interactions.
In this slide, we will take a closer look at what OAuth 2.0 is and its fundamental components. OAuth 2.0 is an authorization framework designed to allow third-party applications to securely obtain limited access to user resources without exposing user credentials. This framework offers a structured way to grant controlled access, ensuring a higher level of security. OAuth 2.0 consists of 4 key components. 1. Resource owner, typically the user who owns the data being accessed. The resource owner has the ability to grant access permissions to third-party applications. 2. Resource server. This is the server that hosts the resource or API. It is responsible for accepting and responding to protected resource requests using access tokens. 3. Client. The application that requests access to the resources on behalf of the resource owner. The client needs to obtain authorization to access these resources. 4. Authorization server. The server that issues access tokens to the client after successfully authenticating the resource owner and obtaining their authorization. It plays a critical role in the OAuth 2.0 flow by securely handling the authorization process. These components work together seamlessly to ensure that the right access is granted to the right parties under controlled conditions, thereby protecting both user data and system resources.
The Client Credentials Grant is an OAuth 2.0 flow that authorizes applications to access resources about themselves without requiring user context. It's particularly useful for situations where you have machine-to-machine interactions, back-end service authentications, or automated processes such as cron jobs. In this grant type, the client application will make a POST request to the authorization server, providing its client ID and client secret. This request is formatted as shown in the example command on the slide. Bash curl x_h content type application xw double form URL encoded. 90s grant type equals client credentials and client ID and client secret ht authorization server.com/token. By successfully providing these credentials, the authorization server will issue an access token in response. This access token can then be used by the client to authenticate requests to the resource server, thereby securing access to protected resources. The main takeaway here is that the Client Credentials Grant is efficient for scenarios where user authentication is not necessary, and we need reliable, secure access between two server-side applications or automated tasks.
Let's walk through the steps involved in the Client Credentials Grant flow. Step 1. Client ID and secret. First, the client application needs to securely store its client ID and secret. These credentials are required for the authentication process. Step 2. Token request. Next, the client sends a POST request to the authorization server. This request includes the client's ID and secret, along with the grant type, which in this case is client score credentials. Step 3. Access token issued. The authorization server verifies the credentials. If they are valid, It responds with an access token. Step 4, API request. Finally, the client uses this access token to access protected resources by attaching it to the API request headers. Here's an example of the token request using curl. Bash curl x post type application x type form URL encoded. 9 is D grant type equals client core credentials and client ID and client secret. S authorizationserver.com/token. This command sends the necessary parameters to the authorization server and, upon successful authentication, retrieves the access token for subsequent API requests. By following these steps, machine-to-machine interactions, back-end service authentications, and automated processes can securely access protected resources without requiring user context. The password grant method is used to exchange a user's credentials directly for an access token, making it a highly efficient and straightforward process appropriate for trusted clients only. For example, if you have a mobile app that you trust and manage, you can use it to simplify authentication by directly collecting and sending user credentials to obtain an access token. This minimizes the complexity of handling tokens and improves user experience. Let's look at the command example. Bash curl dex post -h content type application x form -u grant type -d grant type equals password and username a username and password user password and client ID /authorizationserver.com/token. In this command, you'll replace username and user password with the end user's credentials and client ID with your app's identifier. The server will then return an access token that your client can use to access protected resources. This grant type is most suitable for scenarios where the client application is highly trusted, such as native mobile applications or applications maintained by the same entity that owns the authentication server. Essentially, it's best used in scenarios requiring direct interaction with end-user credentials. In this slide, we are going to walk through the steps involved in the password grant flow, which we briefly mentioned earlier as being suitable for trusted clients like mobile apps. 1. User authentication. The process begins when the user submits their credentials, typically a username and password. 2. Token request. Next, the client sends these user credentials along with the client ID to the authorization server. This is done via a command, such as the curl command example provided. 3. Access token issued. Upon successful authentication, the authorization server returns an access token to the client. 4. API request. Finally, the client uses this access token to access protected resources on behalf of the user. The example command is crucial for understanding how this flow works in practice. Here's a detailed breakdown of the curl command provided. Bash curl x post h, content type, application x data form 4 encoded, grant type equals password, and username and password equals user password, and client ID equals authorization-server.com/token. This command sends an HTTP post request to the authorization server, specifying the grant type as password and including the user's credentials and client ID. In return, the server issues an access token if the credentials are valid. Understanding these steps will help you implement the password grant flow effectively, ensuring secure and efficient access to protected resources. When implementing the client credentials grant for OAuth 2.0, there are several security considerations to keep in mind. This grant type has the advantage of confidentiality for client credentials and limiting the access scope to machine-level operations, which is particularly useful for server-to-server interactions. However, it is essential to be aware of the cons, such as the potential exposure of the client's secret. To mitigate these risks, it is best practice to use encrypted channels like HTTPS to protect data in transit. Additionally, rotate your secrets regularly to minimize the impact of any potential exposure. Another crucial step is to restrict the API scopes and permissions to limit what each client can do, thereby reducing the surface area for possible misuse. By following these best practices, you can improve the security of your implementation and protect sensitive information effectively.
In this slide, we are discussing the password grant type. One of the main advantages of the password grant is its simplicity and direct approach to user authentication. This makes it an easy method to implement and use. However, this simplicity comes with some significant downsides. The primary concern is the potential exposure of user credentials, which poses a high security risk. It's also not recommended to use this method for public clients, as it's more vulnerable to attacks. To mitigate these risks, you should implement multi-factor authentication. This adds an additional layer of security beyond just the password. It's also advisable to avoid using the password grant for third-party or untrusted clients as a security precaution. Lastly, make it a practice to regularly monitor and log access activities. This helps in detecting any unauthorized access and enables you to respond promptly to any security incidents. When securing client credentials and handling user passwords, it's vital to follow best practices to protect sensitive information. Let's explore some practical tips. Firstly, to secure client credentials, you should always store secrets securely. This can be achieved by using environment variables or secure vaults dedicated to this purpose. Regular audits of access and usage are also essential to ensure credentials are not compromised and are being used appropriately. Now, for handling user passwords, ensure that credentials are validated securely during authentication processes. It's crucial to avoid storing passwords in plain text to protect them from potential breaches. Instead, use password hashing algorithms like bcrypt to enhance security. By incorporating these practices, you strengthen your overall security posture and mitigate potential risks. In this slide, we'll dive into a real-world scenario focusing on identifying and exploiting SMB vulnerabilities. For our example scenario, we discovered misconfigured SMB shares during our investigation. To address this, we performed a series of actions. First, we used OpenVAS, an open-source vulnerability scanner, to identify potential security issues within the SMB shares. We then utilized Metasploit to exploit these vulnerabilities and validate our findings. To prevent such vulnerabilities, we recommend enabling SMB signing to mitigate tampering risks and regularly updating and patching SMB services. These measures are critical for maintaining a secure network environment. In this slide, we're wrapping up our discussion with a conclusion. Let's summarize what we've covered in this module. We've delved into the understanding of client credentials and the password grant, examining their best practices for secure implementation. Additionally, we discussed real-world application insights to ground these concepts in practical scenarios. As we part, let's reflect on the critical takeaway. Security is not static. It is essential to stay updated with the latest best practices. Continue your learning journey and don't hesitate to share knowledge with your peers. This collaborative effort is vital in maintaining robust security in our dynamic field.
For further enrichment of your knowledge on the topics we've covered, I highly recommend delving into these additional reading materials. Start with the OAuth 2.0 framework documentation for an in-depth understanding of the protocol itself. Then, explore the Security Identity Server documentation on the client credentials flow to see how it's implemented in a real-world system. Additionally, check out Microsoft's documentation on OAuth 2.0 for another perspective on best practices and implementation techniques. These resources will provide a solid foundation and further your expertise in secure OAuth implementations. Thank you for your attention to the course. I hope you found the material engaging and informative. If you did, please consider leaving a like to show your appreciation. Feel free to comment below with any feedback or questions you may have. Your input is valuable and helps us improve. Don't forget to subscribe to the channel to stay updated with future content. Lastly, if you think this course would benefit others, share it with your friends and colleagues. Your support is greatly appreciated.